This video demonstrates the operation of a DC shunt motor reversing starter. If either the direction of the field current or the direction of the current flow through the armature of a wound DC motor is reversed, the rotation of the motor will reverse. If both of these two factors are reversed at the same time, however, the motor will continue rotating in the same direction. In this scenario, the DC shunt motor is reversed by changing the polarity and resulting direction of current flow through the armature. When the forward starter coil is energized, the main F contacts close, connecting A1 to the positive side of the power supply and A2 to the negative side to operate the motor in the forward direction. When the reverse starter coil is energized, the main R contacts close, reversing the armature polarity, so A2 is now positive and A1 is negative, and the motor will operate in the reverse direction. Note that for both the forward and reverse directions, the polarity of the shunt field remains unchanged. The circuit is electrically interlocked by way of the normally closed R and F auxiliary control contacts. This prevents starter coils F and R from both being energized at the same time, in effect shorting out the motor armature circuit. If the reverse push button is pressed while operating in the forward direction, the reverse starter coil cannot be energized as the circuit to the coil is opened by the normally closed F contact. In order to change the direction of rotation, the stop push button must first be pressed to de-energize the forward starter coil and allow the normally closed F contacts to return to their closed positions. This video demonstrates the operation of a three-phase reversing motor starter. Interchanging any two of the three main power lines to a three-phase motor will reverse the direction of its rotation. Energizing the forward coil F connects L1, L2, and L3 to motor terminals T1, T2, and T3 respectively. Energizing the reverse coil R contacts L1, L2, and L3 are connected to terminals T3, T2, and T1 respectively, and the motor will now run in the opposite direction. Once started, the motor will continue to run. With a phase loss, as with a single-phase motor, the current drawn from the remaining two lines will almost double and the motor will overheat. The motor will not start from standstill if it has a loss F phase.